Hey there! Today I'm diving into the fascinating world of process management in operating systems. Buckle up! We're about to get technical, but I promise to keep it engaging. First things first, what is a process? Well, a process is essentially a program in execution. Think of it as a living, breathing entity that needs resources like CPU time, memory, files, and I/O devices to get its job done. Unlike a static program, which is just a file sitting on your disk, a process is active, with a program counter ticking away, guiding it from one instruction to the next. Now let's talk about process states. A process can be in various states: new, ready, running, waiting, or terminated. Imagine you're baking cookies. New is when you've just decided to bake. Ready is when you've assembled all your ingredients. Running is mixing the dough. Waiting is when the dough is chilling in the fridge. And terminated is when you've finally eaten those delicious cookies. Each process has a unique ID and a process control block, or PCB. The PCB is like the process's passport, containing crucial information like its state, program counter, memory limits, and I/O devices in use. It's stored in a protected area of memory, far from the reach of regular user processes, because it's super important. Let's not forget about threads. A thread is a segment of a process and is often called a lightweight process. Threads share memory and resources but can run independently, boosting the application's performance through parallelism. Imagine a thread as a worker bee in a hive, working alongside other bees to build a honeycomb. Process scheduling is another critical aspect. It's all about efficiently switching the CPU among processes to keep things running smoothly. There are three types of scheduling: long-term, medium-term, and short-term. Long-term adds new processes to the pool, medium-term manages the swapping of processes in and out of memory, and short-term, or CPU scheduler, decides which process gets to run next. Now let's touch on context switching. This is the mechanism that allows multiple processes to run on a single CPU. When the CPU switches from one process to another, it saves the state of the old process and loads the state of the new one. It's like a conductor switching between different sections of an orchestra, ensuring each one gets its time to shine. Finally, we have operations on processes. This includes process creation and termination. Processes can create child processes, forming a tree of processes. They terminate when they complete their task or encounter an error. Think of it as a relay race where each runner hands off the baton to the next. So that's a quick deep dive into process management in operating systems. I hope you found it as intriguing as I do. Remember, understanding these concepts is key to mastering computer science. Until next time, keep exploring and keep learning.